Prepare for a truth revolution.
Actually, you can prove God exists.
Questioning tradition, because what you've been taught isn't always true.
The truth will set you free.
Welcome to Truth Revolution. This is where faith and reason meet. I am Pastor Dave. This is Pastor Jeff from Revolution Church. We got a great show lined up for you today.
Oh, yes. A couple weeks ago, we had a guest on. It was Dr. Hugh Ross, and he talked about aliens and demonic activity, occult activity. Really interesting discussion.
Right.
I got a lot of feedback about that. Did you get some
Yes,
feedback?
I did. And it was both like good and bad. They're like, what? Oh, that's so cool. What?
Yeah,
That's crazy.
yeah. I had people going, that. I had one guy text me. He actually texted me. He's like, I gotta. That was the best show I ever listened to.
Yeah.
And then I had another guy. He was like, I don't know what I just heard.
Right.
All the aliens and demons, and that was crazy. So, and so it was just a great show. So we're bringing him back again.
Right.
This is Dr. Hugh Ross.
All right. Astronomer and best-selling author and regular guest on Truth Revolution. We can say that now.
Yeah.
Hugh Ross travels the globe speaking on the compatibility of advancing scientific discoveries with the timeless truths of Christianity. His organization, Reasons to Believe, is dedicated to demonstrating via a variety of resources and events that science and biblical faith are allies, not enemies.
Dr. Ross, so glad to have you on the show again today.
Oh, my pleasure.
All right, it's always great to have you. And I'm serious. The response we got from the show when you came and talked about aliens and occultic activity, a lot of great response to that. Do you always get a lot of response when you talk about that?
Yeah, especially when you go to countries where there's a lot more occult involvement.
Oh, probably because they see some of that firsthand.
They get to, you're right.
Okay. Well, today we're not specifically talking about aliens and occultic activity. That show kind of led into this idea of what's the likelihood that there are aliens out there. And we touched on it a little bit. Well, today we're actually diving all the way into that idea. Of course, we're going to answer Bible contradiction like we always do. You can get out to truthrevolution.tv if you'd like to donate to the show. If you want more information about Reasons to Believe and Dr. Hugh Ross, you can get to reasons.org. They accept donations as well. They're donor run. And so good stuff to do at truthrevolution.tv as well as reasons.org. You can listen to our past shows at truthrevolution.tv.
Right. Truth Shots. You can donate if we thank you. Everybody that's been supportive so far.
Absolutely. And of course, we're from Revolution Church in Salina, Kansas, which if you want to come to our services, 9, 11, or 5 p.m. That's 9 a.m., 11 a.m., or 5 p.m.
Right. Don't be showing up at 9 o'clock at night.
Yeah, don't be doing that. So you can come to our services, or you can just watch us live online if you get to our website. So let's jump into this. Dr. Ross, you actually have a new book coming out. It's called The Improbable Planet. Give us just a little bit of insight into what this book is about.
Yeah, Improbable Planet is a book where I talk about fine-tuning from a completely different perspective. What does it take to get a planet where you can have billions of human beings living on it at one time, billions of intelligent beings, where they have the technology, where they can communicate with one another, truths about creation and understand that. And so I really prefer the title, Habitability for Redemption, making the point that in the entire history of the universe, the entire history of Earth, there's a very tiny sliver of time when it's possible for billions of human beings to live at the same moment on the Earth. And by the way, that window of time is quickly coming to a close. So this is the time to get truth out there, because very soon, at least on an astronomical time scale, that window will close. There's just a 10,000-year wide window where you've got the climate stability and the optimal temperature and the kind of geography on the planet. And what's most important, that you've got the design ice age cycle that makes it possible for billions of people to live here at one time.
Okay, we're going to dive into that time scale a little bit more. I want to do a little bit later. We're also going to dive into some of the probabilities that make life habitable on the planet. But I mean, you're talking about, if you're right, that means life as we know it won't exist on Earth in 2,000 years. Is that correct?
Well, the technology level that we're experiencing, the capacity for the planet to support billions of people, yes, that's going to close in at most, I would say, about 1,500 years. And some people argue it could happen even in 100 years.
In 100 years? Now that seems crazy.
Keep in mind that, we've only had an ice age cycle for the last 2.5 million years. Most of the history of Earth, there's no ice at all. Other times you got like 60 to 80% of the planet covered in ice. We're living in a unique time when the planet oscillates between 10 and 23% ice coverage. And to have billions of people, you need to be in that 10% window. But of all the ice ages we've had over the 2.5 million years, we're living in the only one where you got climate stability. What's typical is that the temperature will jump up and down by 24 degrees Fahrenheit.
Mm-hmm.
With the temperature jumping up and down by that degree, it's impossible to sustain any kind of large-scale agriculture. And without large-scale agriculture, you can't have a large population of human beings, let alone any kind of technologically advanced civilization.
So, okay, forget about coming back to this later. We
got to do it now.
100 years, we don't have time to wait. Let's talk about it right now. So, okay, explain a little bit more detailed what types of technology won't be available when this ice age cycle completes.
Well, because of the ice age cycle in which we're in, and because right now we're between two major ice ages, we're in what's called an interglacial, where you only got 10% ice coverage.
Mm-hmm.
But it is the only interglacial that Earth has ever experienced where the global mean temperature hasn't varied by more than 1 degree centigrade over the past 9,000 years. Typically, it varies by 18 degrees centigrade. And when it varies that much, you really can't plant a specialized cultivation. So what was going on during the last ice age, for example, humans were very technologically motivated. But because they could not grow a surplus of food, they really couldn't afford to have people dedicated to advancing technology. And the farms were such that people would be planting, say, 1, 2, or 3 acres, but they would plant 12 crops. 8 crops would fail, and they would feed their family on the 4 that made it, but they never knew which of the 4 crops would make it. Similarly with the animals that they were taming. They wouldn't know which ones would survive and which ones wouldn't. And so because of this extreme climate instability, it was impossible for humans to engage in sufficiently efficient and specialized agriculture that you could grow enough food to be able to sustain people who could focus on engineering, science, philosophy, and mathematics, or to grow enough food where instead of having 1 million human beings on the face of the earth, you could actually have billions.
So, okay, to bring this just to summarize that, essentially, the number of people who had to work as farmers during that time period is way greater than the percentage of humans who have to be farmers nowadays, because is that correct? Am I understanding that?
Right. You're talking about a time where 98% of the population was engaged in mere subsistence. They worked all day just to come up with enough food to take care of themselves. There was no time left for engaging in other activities to any significant degree. Whereas today, that percentage is down around 2%. I mean, less than 2% of Americans are growing the food that we eat. So the other 98% can engage in other activities. Moreover, we can grow a huge abundance of food. I mean, thanks to the fact, we're basically living off of the resources of the last ice age. I mean, you've got melting glaciers that are feeding the great rivers. And at the end of the last ice age, you had this transfer of aeolian dust from the high plateaus down to the agricultural plains. So thanks to the fact that we live in an ice age cycle, we have these massive agricultural plains that are being fertilized and watered to a degree that, say, in India and China, you can feed 3.5 billion people off the produce of those agricultural plains. That's impossible unless you're in an ice age cycle, and it's impossible unless you're in an interglacial where you've got extreme climate stability. I think part of the attractiveness of this book is that many people today take climate stability for granted. And part of what I communicate in this book, it's an extreme exception. We're living at the only time,
There we go.
only time in the history of our planet Earth where we've had this unique time window.
Yeah. Okay. Now, the last, or when this interglacial began, was that about 800 years ago?
The interglacial that brought into effect extreme climate stability began 9,000 years ago.
Right, but
12,000 years ago, the temperature was rising at a predictable rate, and 12,000 years ago, you got what's called the Neolithic Revolution, when finally humans begin to engage in specialized agriculture. But when climate stability kicked in, it was able to be greatly expanded. But it's only been in existence for the past 9,000 years.
Okay. Now,
what we know about the history of the Earth is it'll last for at most 1,000 to 1,500 more years.
Okay, and so I remember seeing the graphs about that. I mean, you can look up graphs online. You just type in climate history of the world, and you'll see this giant fluctuation, and all of a sudden it kind of comes up and stabilizes off. I remember seeing graphs like that over the last 10,000 years. I could have sworn, and I mean, maybe I'm not, maybe I'm wrong. I could have sworn that I had talked with you or someone from Reasons, and they had said something about the last dark ages. There was something that changed too that allowed the technology to come about in the way it has in the modern time. Maybe that wasn't it. Maybe I'm thinking about something else. But so basically, we have 100 to 1,500 years before this interglacial period is over. Don't you think people might argue that the technology that we've developed would allow us to continue to farm in places that were inhospitable 12,000 years ago?
Well, the problem is we're going to be entering a climate phase where the temperature is going to be jumping up and down in unpredictable ways, literally by 24 degrees Fahrenheit. And with that kind of unpredictable temperature change, you're simply not going to be able to say, I'm going to plant a 10 square mile farm where all I'm going to grow is winter wheat. You have a very high probability of getting nothing. I mean, that's the advantage today, is that we can do hyper-specialized agriculture because we can count on the climate remaining stable. Where it's not stable, you're basically going to be forced into small mixed farms where you're counting on 90% of what you plant is going to be destroyed, and you're going to survive on the 10% that's left over. Whereas consider this situation today. You can plant a crop and know that you're going to get a very good productivity from that land. So that's how we drive our agricultural industry.
Okay.
But it's fundamentally dependent on extreme climate stability.
Okay, so we're gonna come back in just a little bit. We're getting close to the break, but we want to start getting into this idea about how does this relate to God, and why are we talking about this? Because our show is not about farming or climate change. Our show is about God, and what are the odds that this stuff sort of happened? You know, we got a couple minutes for the break. Give us a little breakdown. Where's God in this picture? Why do we think this is a big deal?
Well, thank you for giving me that lead, because we're in that part of the history the sun's burning where we shouldn't have any ice at all, because the sun gets brighter and brighter as it gets older and older. So it's just miraculous that we've got ice at this time in Earth's history. We now understand what's responsible for the ice. It's 5 simultaneous, unique, and unprecedented tectonic events that happened 3 million years ago.
Seriously.
For example, you've got North America and South America joining together. That stopped the flow of warm Pacific Ocean.
Okay, hold on a second. We're going to have to come right back to that. Yeah. Because we got the music coming in and it's cutting things out. So, all right.
We got to find another planet.
There's 5 tectonic events happening, and listeners have no idea what's going on right now because the music cut them off. Oh, sorry about that. All right. We're using a Skype connection that only allows sound to go one way right now, I think. Yeah. All right, so we're going to be right back. We're going to do a Bible contradiction, but more importantly, you're going to find out what those 5 tectonic events were and when your life is going to end, pretty much.
Well, he did say 100 years to 1,000, so I'm pretty much out of the picture by then.
But that's that's like a 1,600 year area. Like, even if there's a 10% margin of error, it could be tomorrow.
Right.
So, all right, we're gonna be right back. TruthRevolution.tv is the website. Yeah. And you better get there because you don't know.
Right. Tomorrow could be it.
There may not be any food left tomorrow. The website's going to go down. And all right, TruthRevolution.tv. We're going to be right back with Dr. Hugh Ross from Reasons to Believe.
Truth Revolution.
And we're back.
Yes.
I am, during the break, I went and started packing my bags and looking for the next shuttle off this planet.
Yeah, well, you better, man. You only got 100 years.
Right.
Or
What about my kids? Think of the kids.
maybe at 1,000. You don't have any kids.
I know. I got to get busy.
It's a good thing you don't have any kids.
Right.
They'd have to face
That's
a very
true.
bleak future.
All right. I feel much better now. Thank
All
you.
right. So, good. All right. So, back with Dr. Ross. We got interrupted there. You were telling us, just to summarize, that in the next 100 to 1,500 years, we are going to end the interglacial period that we're in. And we're going to start seeing a change in the way we farm. The glaciers will no longer be providing water. The type of dust, I forget the word you used for it, but the type of dust won't be provided anymore. We won't be able to farm specialty things in mass quantities anymore. And so many more humans are going to have to be devoted to farming just to sustain their life, rather than having the vast majority of the population doing whatever else they want, studying philosophy off your mom's paycheck,
Right.
Whatever it is. So we'll have to change. All of that will change in the next 100 to 1,500 years. And you were saying that there were 5 tectonic related events that went along with this.
Yes, because we got the sun at a brightness level today that we shouldn't have any ice on planet Earth at all. But what has cooled the planet, so we do have an ice age cycle, are these 5 tectonic events. The one we mentioned before the break was a joining together of North and South America. So now you've got the Isthmus of Panama, and that cut off the flow of warm Pacific Ocean water into the Atlantic, and that had a cooling effect on the planet. You also have Antarctica breaking off first from Australia and then from South America, and then moving down and settling right on the South Pole. But it created a huge ocean mass all the way around Antarctica, which generated an ocean circulation called the Roaring Forties, resulted in Antarctica getting thousands of feet of ice. And that ice reflects away solar radiation. So it helped cool the planet, and the circulation cooled the entire Atlantic Ocean. Then you got Greenland, which was situated off of Newfoundland, and it tectonically moved forward by 1,800 miles northward, up towards the North Pole. And as it approached the North Pole, it settled over what's called a hot spot, which caused the landmass of Greenland to jump up by about 9,000 feet, which meant now we had a very cool condition, which allowed all of Antarctica to be covered with ice. And if you look at the globe, you'll notice that the Arctic Ocean is almost entirely enclosed by continental landmasses. This is what permitted the formation of the polar ice cap. But the most significant event of all was India breaking off from Madagascar and moving towards Asia at the high velocity of 22 centimeters per year.
Wow.
And it crashed into Asia, generated the Himalayas, and caused the Tibetan Plateau to uplift, so that today there's more ice in that region than there is in the polar ice cap. And being close to the equator, that ice pack reflects away a lot of solar radiation. The simultaneous occurrence of these 5 tectonic events cooled the planet enough that we can have this ice age cycle. And it's cyclical because the planet is delicately balanced between a huge amount of ice coverage and no ice coverage at all, where the slight variations in the orbit of the Earth generates a cycle. So, for example, the shape of the Earth's orbit changes slightly with a 100,000-year cycle. And as a 100,000-year cycle, it explains why our Earth today oscillates between 20% or more ice coverage for 90,000 years and then 10,000 years where you got 10% ice coverage. And so it's a change in the eccentricity of Earth's orbit that causes us to go through this cycle of 23% ice and 10% ice. But for humans to be able to exist in a civilized state, you have to be in the warm interglacial with just 10% ice coverage. But if you look at all the ice ages that preceded us, when you were in interglacial, the temperature was jumping up and down radically. What's unique about this ice age cycle is that we have this extreme climate stability. And that's what enables our planet to support billions of people instead of just thousands of people.
And so when you say what's unique about this cycle, give me a number of times. In the last 4 whatever billion years on Earth, how many times have the conditions been just like this?
Never. This is the only time.
Never.
Never, right.
So, we're looking at a once in a multiple billion year occurrence here, where you have these 5 tectonic events, the North and South America coming together, Antarctica going down to the south, creating those oceans. You have Greenland going up 1,800 miles north, becoming much colder. I missed the 4th one. What was the 4th one?
4th one was the enclosure of the Arctic Ocean with these continental land masses.
Okay.
Siberia, Canada, and Greenland basically making an Arctic lake, which enables an ice cap to form.
Basically a freezer. Okay. And then we have India moving towards Asia, creating the Himalayas, and lots of ice being created up higher. And if those 5 things hadn't happened, the sun right now is hot enough that would have melted all the ice on Earth.
Yeah. If you take away one of those 5 tectonic events, we would not have an ice age cycle. We'd have no ice at all.
Almost like it was planned that way.
Even if you take away one of them?
Yeah, that's how delicately balanced it is. You need all 5 to occur simultaneously. The other thing that you see in the fine-tuning is that this happens after 3.8 billion years of life history. And it takes those 3.8 billion years of life history to build up the mineral resources and the biodeposits so we can actually launch a global civilization. I mean, just think of all the coal, the oil, the natural gas, the limestones, and the thousands of minerals generated by that life. Wasn't for that long history of life, yeah, we could have human beings here, but we have no capability of launching and sustaining civilization.
Okay, so you have these 5 tectonic events, but if they occurred at any other time before the 3.8 billion years up to now, it wouldn't have mattered. And if the sun would have been hotter before now, that wouldn't have mattered. And the way our Earth rotates around the sun is just right. And because we have just exactly 10% ice coverage, that's right. All these things occur to make it just right for the amount of farming we're able to have, the amount of food we're able to have, to be able to produce the type of technology that we have right now.
Yeah, there's more to it than that. So, for example, the grains that we use to feed our planet, they're recent. I mean, you go back a few million years, our planet didn't have any grains. And notice all the grains show up at the same time that we need to grow this huge food supply.
What a coincidence!
Yeah, really.
Yeah. And the other thing is that until now, our planet was being bathed with radiation from nearby supernova events. I mean, our galaxy has a supernova eruption about 3 times per century.
Whoa.
And yes, we do see these supernovae erupting, but what's unique about this 9,000-year window we're in, no nearby supernova. A research paper got published documenting all the nearby supernova that occurred during the last ice age, 23 of them. And yet for the last 9,000 years, not a single nearby supernova.
Okay, why is that significant?
That's significant because if you got a nearby supernova, that's going to damage our atmosphere, especially our ozone shield. It's going to expose us to radiation. All of that is nasty for advanced civilization. You want the supernova to be far away.
Okay. Please tell me that this sort of information is in your book, The Improbable Planet.
It is, and a whole lot more. Okay. I basically document how every era of geology, it's crucial to enable billions of people to live here on planet Earth. I mean, I got one chapter on what's called the boring billion. It's a billion-year period in the history of the Earth that we thought was very uninteresting. We now know it's incredibly interesting, and if the boring billion weren't exactly as boring as it is, there'd be no possibility for human beings on this planet today.
Awesome. Okay.
We celebrate Thanksgiving. We're going to be thanking God for the boring billion.
All right.
Might be our last one.
Yeah. We're gonna, it might be. Okay, so we're going to jump out of this for a minute. You got to get his book. His book drops on September 6th. You can find that at reasons.org. Let's jump in and do a Bible contradiction right now.
Bible contradiction.
All right. Bible Contradiction today brought to you by the Freedom from Religion Foundation. When was Adam actually created?
Okay.
Genesis 1:12 through 31 said, "And the earth brought forth grass, herb yielding seed after its kind, and a tree yielding fruit, whose seed was in itself after its kind. And the evening and the morning of the third day, and God said, let us make man in our own image. And the evening and the morning were the sixth day." That's really condensed in case you didn't know.
So basically, God made trees, then God made people.
Right. Genesis 2:5 through 9 says, "And every plant of the field before it was in the earth, and every herb on the field before it grew. For the Lord God had not caused it to rain upon the earth, and there was not a man to till the ground."
Okay, so before they grew.
Right. "And then the Lord God formed man from the dust of the ground, and the Lord God planted a garden eastward in Eden, and there he put the man whom he had formed."
Okay, so the Freedom from Religion Foundation is saying Genesis 2 says that people existed before the garden.
Right.
This is simple. Just give a little credibility. All you have to do is look at verse 7, and it says, "Then God formed the man." Then, all right? It's just telling you, hey, there was no shrubs because God hadn't sent any rain, but streams came up. Then God made a man. So it's just saying later on God made a man. This is not. All you have to do is just give it a little credit. Our cracked acronym, the second C stands for credit. Give a little credit. Don't read it violently. Just read it trying to understand what it's saying.
Gotcha.
Read it violently. Okay, we're going to go to our podcast. So for those of you listening on the radio, you need to get to truthrevolution.tv. You need to get this podcast.
Oh, yeah.
Because we're going to have
maybe the last one we have.
It may be the last one we have. We're going to talk more with Dr. Ross about the next 100 to 1,500 years, as well as 400 other factors needed for life. God put this together, people. We'll see you next time.
Truth Revolution.
And now we're online. This is the podcast.
Okay, so God's put together some very, very unique situations here. There's the supernova has ceased to explode. The exact time that we reach the 3.8 billion year mark, where we have the right mineral resources. The exact same time North and South America came together. The exact same time Antarctica formed in the proper place. The exact same time Greenland went north 1,800 miles. The exact same time the enclosure of the Arctic Ocean happened. The exact same time India collided with Asia and created the Himalayas. The exact same time the Earth's orbit around the sun happened in the right place.
This is very similar to the whole probability that Jesus is the Son of God.
Wow.
Type thing.
Yeah, you're right.
I want to come up with the odds. What are the odds of all that stuff happening?
What are the odds of those things
all
happening?
At the same time.
I mean, we look at playing Powerball, and I don't really play. You pick 40 out of numbers out of 40.
I have no idea.
I think it's like you pick 5 or 6 numbers out of. Dr. Ross, do you know? Do you ever play Powerball? How do you play that?
I never played Powerball, but what I have done is develop a calculation. What is the probability without divine miraculous intervention?
Okay.
You're going to get these hundreds of fine-tuned features.
Yeah.
All coming together. It's much less than one chance in 10 to the 1,200.
10 to the 1,200?
Yeah, which is roughly the probability that you're going to win the California lottery, get all those Powerball numbers just right, that you're going to be able to do that 160 consecutive times. You
Wow.
buy just one ticket each time. The mathematician friend of mine put it, it's no different than the probability of winning the California lottery 160 consecutive times where you buy no tickets at all.
Yeah, exactly. Exactly. Like you might as well just find 160 tickets on the street that win the lottery 160 times in a row.
Awesome.
Yeah, that is just ridiculous. I mean, you're totally right, Dave, because the probability we've looked at the California lottery and we compared it to the probability that Jesus fulfilled the predictions that he fulfilled, and it was astronomically impossible. I think it was like I'm not going to quote that right now, but it's something crazy like that. But 10 to the 1,200th power. I mean, that's basically the mathematical definition or equivalent of impossible, isn't it?
Well, that's something my physics professor taught me when I was a freshman physics student, that if you can demonstrate that something is less than one chance in 10 to the 50th of happening, that's equivalent to proving that it's impossible. And guess what? We got 1,100 more places of the decimal to throw in than just those 50.
Right, and we're living in it, and so it's like people can't say, that didn't happen.
Yeah.
We're living in it.
Oh, exactly. That's the weird thing. I mean, just to give people a little perspective, I mean, the lottery one's great, but like the difference between $1 and $1 million is 6 zeros.
Right.
But the difference, what we're talking about here is not 6 zeros. We're talking about 1,200 zeros. I mean, or 1,201 zeros.
Yeah.
I mean, that's ridiculous. So but it happened, as Dave said. This happened. What does that imply?
It implies that we must be here by the intention of a miraculous, supernatural, super intelligent creator. By natural process, it's just not going to happen. Therefore, we look for a supernatural explanation. And that's where the space-time theorems, I think, are important. Because those space-time theorems say that if general relativity is true, and if the universe contains mass, and looking at the two of you, I see that you're proof that the universe contains mass.
You calling me fat?
I would say that some people are more proof than others. That's a diplomatic way of putting it. So, but the whole point is nobody questions that the universe contains mass. No physicist questions that general relativity reliably describes the movements of bodies in the universe. If those two things are true, space and time are created, implying there must be an agent beyond space and time that created the universe, which means no scientist today can deny the possibility of miracles in the realm of nature. That's the biggest miracle any scientist could hope to uncover. And if that God that created the universe performed that kind of an outstanding miracle, then certainly he may have performed other miracles. Therefore, we need to be open-minded enough to look at the scientific evidence and say, does this better fit a natural explanation or a supernatural explanation? And this time window that we see where human civilization on a global scale can be achieved, I think is an example where you have to say, this is supernatural, it can't be natural. You need thousands of things to line up exactly just right to make it happen.
Yeah. Now, what would be your argument for the person who comes back and says, well, I mean, you put these 5 tectonic events in there and, you know, the age of the Earth in there, and you did these mathematical equations, but what are the odds that I'm going to end up in my office today and that it's going to be exactly 98 degrees outside and that, you know, there's going to be exactly 28 clouds in the sky? I mean, the odds of that is 1 in a million too, isn't it?
It is, but I think what's different here is that we're talking about something that's testable. If this is really the signature of the supernatural handiwork of God, then the more we study this narrow time window, the more evidence we're going to accumulate that indeed we're looking at something supernatural rather than natural. And hey, this book is coming out in just a few days, but even in the last few days, scientific research papers have been published that I wished I had included in this book because it makes a stronger case for my argument. And so I have a blog piece that I put on our website basically telling you, hey, even though only a few months have gone by, our case is stronger. And that's what the Bible tells us. Look at the trend line. One way we know it's the handiwork of God is that the more we study the book of nature, the more evidence we accumulate for God's supernatural handiwork.
Wow, that's
now,
awesome.
If it wasn't God, then the more we would look, the more evidence we would see for the natural. But just like we can put everything else to the test, we can put this to the test as well.
You know, it's almost like your book, which comes out September 6th, which this is being recorded, this show is, but this show gets released on September 7th. So your book's been out for 1 day right now. And your book actually, in some ways, is kind of the antithesis of your former professor, Carl Sagan's idea that there's nothing spectacular about the Earth at all.
Well, that was several decades ago, and during those decades, we've learned a lot more about our galaxy and stars and planets. We now know, for example, that every single planet in our solar system and every one of the 5 asteroid and comet belts plays a critical role in making advanced life possible here on planet Earth. The fact that even the Kuiper belt of comets has to be extraordinarily fine-tuned to make advanced life possible here tells us this isn't just a sheer coincidence. Everything we see in the universe, literally every life form that's ever existed in the history of the Earth, plays a role in making advanced life possible. There's nothing wasted. And I think that counters the Sagan argument, because people like Sagan say, we look at this vast universe and it seems like a huge waste if God only wanted life here on planet Earth. We now know that that's incorrect. Literally, every particle of our universe, every life form plays a role.
In fact, I believe it's AJ, one of the scholars at RTB, has done some writing or some research on viruses and how they contribute to life being able to flourish on Earth.
If it wasn't for viruses, we'd be overrun by bacteria. Viruses have control of bacteria. They also provide a food supply for a huge amount of life. And as an astronomer, I can tell you this. If it weren't for viruses, we wouldn't have the rainfall and the snowfall that we need to sustain advanced life.
Now,
viruses and viral particles actually seed our rain clouds to a significant degree. They break down bacteria, and the broken down pieces of bacteria that have been caused by viruses also play a big role in seeding the clouds. So yeah, we wouldn't even have the rain for the crops we need if it wasn't for all these bacteria being exactly the way they are.
now I've heard it all.
Yeah.
Well, that's just crazy. Okay, so I actually, and Reasons to Believe has a list on their website, on reasons.org, and we're going to link to this, a list of over 400 things needed for complex life.
Let's just move our website over to theirs.
Yeah, let's just redirect it. Just do a redirect on our website. Yeah, but like, okay, number one on the list is the galaxy cluster type. If it's too rich, the galaxy collisions and mergers would disrupt our solar orbit. But if it's too sparse, there's insufficient infusion of gas to sustain star formation. Okay, that's self-explanatory enough. That's fine. But let's go to something I don't understand. White dwarf binaries. This is number 9 on your list. Okay, it says if there's not enough white dwarf binaries, that's a type of star, insufficient fluorine would be produced for life chemistry to proceed. But if there's too many, planetary orbits would be disrupted by stellar density. Tell me, what do you mean by that?
Okay, we need fluorine to sustain life. It's one of the crucial elements for life.
It's needed for life.
Fluorine is only made in a few places in the universe. There's some what we call asymptotic giant branch stars that make some fluorine. Other fluorine comes from these white dwarf binaries. We have to have just right quantities of each in order to get the fluorine we need to sustain life, especially advanced life. But you don't want to have too many of these white dwarf binaries. You don't want to have too many of these asymptotic giant branch stars, because now that's going to cause problems by their disturbance for our solar system. So everything we see is just right.
Okay, and so how does this fluorine, this is produced by these white dwarf binaries? I mean, what do they do? Do they produce the fluorine and then they FedEx it over to Earth? Like, what happens? I mean,
Well, yeah, I mean, for example, we now know that our solar system was born in a giant, dense cluster of stars, more than 10,000 stars. And because it was born in such a rich and dense cluster of stars, it got exposed early in its history to these asymptotic giant branch stars, 4 different kinds of supernova eruptions, as well as these white dwarf binaries. And so we wound up being bathed with all the radiation from these stars. That explains why we live in a planet with 92 elements in just the right abundances to make up the atomic chart. However, if we had stayed in that birth cluster, the gravity and the radiation of those nearby stars would have prevented advanced life, even any kind of life, from appearing. What happened once we got enriched with all the heavy elements we need for advanced life is that our sun and its nascent planets received a gravitational kick from nearby stars that ejected us from our birth cluster, sent us from one of the most dangerous places in our galaxy to the very safest place in our galaxy. And we arrived at the safe spot, it stopped. And we've remained there ever since.
That's just insane.
That's just a coincidence. I'm saying, no, everything has to be just right in terms of that kick out and going from the best place to be enriched with those elements to the safest place for advanced life to exist.
And what are the odds that that's going to happen? I mean, that's going to be astronomical.
Yeah.
And right now we're in between the 3rd and the 4th, like the Sagittarius and Perseus arms of the Milky Way galaxy. Is that where we're at?
Right. I mean, because of where we got kicked out to, we only cross spiral arms about once every billion years. It's not typical. Elsewhere in the galaxy, you're crossing the spiral arms much more frequently. And every time you cross a spiral arm, there's significant disturbances. So, for example, one thing I write about in Improbable Planet is that we now know that the sun, as it orbits around our galaxy, goes up and down relative to the plane. As we go up and down, we get exposed to radiation from the central black hole. And so it's no coincidence that we see at an extinction periodicity, about every 30 million years, our planet Earth receives an extinction event. And is generated by the up and down movement. It's also generated when we get close to one of those spiral arms. So we can actually look at the major extinction events in Earth's history and see that they have an astronomical explanation.
And so the other thing that comes to my mind when we hear about these things, and there's over 400 of them, we've just been talking about one, as well as all the specific timeline and when this has to happen for life to occur. I always think about people talking about, there's so many planets and there's so many galaxies, there's billions of planets, like there's got to be other life out there just like us. And it always makes me want to say, maybe there was, but it's pretty unlikely. But even if there was, what would be the odds that they would exist at the exact same time as us and have developed the exact right technology at the exact right time as us? I mean, that would be almost inconceivable. Wouldn't you say the same thing?
Well, I just did a podcast a couple of hours ago here at Reasons to Believe about a paper that just got published where some astronomers calculate that we have to be the first intelligent civilization upon the scene. I mean, these astronomers are not theists. They believe it all happens naturally, but they look at what's necessary to get advanced life on the scene, and they say we have to be the first one.
What do they mean, the first one?
In the future.
The first one where?
Because it literally takes a minimum of 13.8 billion years for it to happen. And we're here 13.8 billion years after the cosmic creation event, and therefore they conclude we have to be the first intelligent species on the cosmic scene. They're arguing maybe that we could have some later, but we certainly can't have any earlier. Therefore, they conclude we have to be alone, because there's no way we're going to get anybody else showing up this soon in cosmic history.
So they're not talking about we're the first in our world's history or in our solar system or our galaxy. They're talking about in the universe.
You know what this means.
Right.
What?
It's bad news. We'll never meet any Klingons.
We're never going to... I think that's good news, Dave. The Klingons were really mean.
Yeah.
Yeah.
Well,
okay. Well, anyway, I want to go to a couple others on your list and have you explain those as well, because I think when people hear this, we start to realize just how improbable these events are and just how likely it is that the hand of God made this happen. So I just want to do maybe one or two others. You got time for one or two more of these? Okay.
Sure.
So I'm going to go to number 203 because I had no idea what this meant at all. Number 203, the rate of quartz reprecipitation on Earth. If it's too low, cycling of silicon would be so disturbed as to affect the production of free oxygen by phytoplankton and the removal of carbon dioxide. If too high, cycling of silicon would be so disturbed as to affect the production of free oxygen by phytoplankton and the removal of carbon dioxide. What is this talking about?
Okay, that's one of many examples of how we live in a planet where nutrients are being efficiently recycled. And it's because we live on a planet where we got oceans and continents coexisting. And so you've got erosion off the continents into the oceans. Then you've got ocean floor material that eventually becomes future continental landmass. So for example, the Himalayas and the Tibetan Plateau were once ocean bottom, but they got pushed up and formed a landmass when India collided with Asia. So there's this recycling that's going on. And it's such that it's replacing the nutrients that get consumed on a regular enough basis that you can actually sustain life on planet Earth for the several billion years that are necessary so that you can have advanced life, not just bacteria, but advanced life on planet Earth. And what I talk about in that list of fine-tuning is the degree of recycling you need of all you're interested in is bacteria. But if you want animals, then you have to fine-tune about a dozen different chemical nutrient recycling mechanisms, silicon just being one. You've got to recycle the phosphorus, you've got to recycle the nitrogen, you've got to recycle the iron, the carbon, so all of these have to be recycled at just the right rates, and it takes just the right kind of plate tectonic activity to make that happen. I think what's exciting about my new book, Improbable Planet, I make the point brand new discoveries that you can't have the just right plate tectonics unless you got the just right life on planet Earth. Life actually played a role in getting plate tectonics started and in sustaining that plate tectonics, because life actually chemically transforms what's happening at the subduction zones between the tectonic plates.
That just seems really crazy to me. I mean, what comes to my mind is the image of a guy with a crowbar on the end of a continent trying to like pry it off or something. But obviously, that's not what you're talking about. How on earth could human life affect that?
Well, for example, we know that early bacterial life on planet Earth, much of it was photosynthetic. And that photosynthetic life actually can precipitate uranium. And the uranium gets precipitated in the subduction zone. And because it's uranium, it gives off heat, provides sufficient heat as to enable the plates to slip under one another. You actually get a mineral called talc that allows it to lower the friction so that you can get the just right plate tectonics. But if you got the wrong life at the planet at the wrong time or in the wrong abundance, then the plate tectonics stops.
I also learned something new. Talc is actually useful for life on Earth.
Pardon?
Talc, you mentioned talc. That's actually
talc,
useful
right.
for life on Earth. I mean, people always use the word talc as like a useless, worthless piece of metal.
Well, talc is a lubricant. I mean, I know women that use talc for their cosmetics.
Yeah.
It's a nice lubricant, but what we see is that you get a special kind of liquid water, what we call class 6 liquid water, at these subduction zones, where you got water at just the right temperature and just the right pressure, and it sets up a chemical reaction where you get talc being produced. And the talc is a lubricant that allows the tectonic plates to slip under one another.
And again, to bring that back, if these other tectonic activities, North America, South America, Antarctica, Greenland, India, hadn't occurred, life wouldn't be able to exist as we know it. And so I'm going to go to another thing on this list of over 400 things. Let's go down to number 330. Actually, you know what? 274. This one was weird. Okay, production of H3 plus by the galaxy's population 2 or second generation stars. Okay, production of H3 plus. If it's lower, there's an inadequate production of population 1 stars, or production of population 1 stars is spread out over too long a period. If higher, production of population 1 stars occurs over too short a period of time. What is H3 plus, and what does the population of 1 stars, why does that matter?
Okay. H3, it's basically a particular kind of hydrogen atom that's ionized. And this H3 plays a crucial role in what kinds of stars form. I mean, it kind of creates a little bit of dust that limits the size of the star, and it governs the efficiency of which stars are produced. And it's such that in order to have advanced life on planet Earth, you need a short history of what are called population 3 stars. These are the firstborn stars that form when the universe only has hydrogen and helium. But as they burn, they produce some elements heavier than hydrogen and helium. And so the ashes from these firstborn stars get incorporated into the second generation, which are the population 2 stars, which are the most common stars in our universe.
Okay.
But as these population 2 stars burn, they generate a much higher abundance of elements heavier than helium, and that's what you need for advanced life. You need to be on a planet that's orbiting a population 1 star. But if you don't have that hydrogen 3 at just the right abundance level, then you're not going to get the right kind of population 1 stars showing up at the right time in the history of the universe to make advanced life possible. So yeah, come Thanksgiving Day, we thank God for hydrogen 3.
Absolutely.
Wow.
And I mean, there's so many other things to thank God for. You should be thanking God for animals that produce methane. That's on their list. You should be thanking God for the level of large-scale turbulence on the protoplanetary disk.
What'd you say?
Yeah. I mean, you got to get over it. We're going to, at truthrevolution.tv, we're going to link to this document. You just got to look at it. You're not going to understand it all, but you just got to look at it. Man, only God could put all of these things together. I mean, Dr. Ross said it was 1 in 10 to the 1200th power that those 5 tectonic events and some of those other things would come together.
Yeah, add all the other stuff in.
We're looking at 400 things.
Yeah. Wow.
I mean,
Well, the nice thing about that compendium, it's 300 pages. We make the entire compendium available free on our website, reasons.org/fine-tuning, and everything is documented. We cite the scientific research papers where these discoveries were made. So yeah, you can check everything out
yeah.
and actually see how the evidence has been getting stronger with respect to time. In fact, if you look at our previous compendiums, what you discover is that the evidence for supernatural fine-tuning design gets approximately 1 million times stronger every month. When I'm speaking on a university campus, I tell the skeptics, if you're not persuaded today, wait 1 month.
Right. You have 1 million times greater reason to believe.
Right.
All right. Wow. Thank you for joining us today. This is great. Again, can you hold up your book one more time so we can see it if you got it nearby you? Again, This is Improbable Planet by Dr. Hugh Ross from Reasons to Believe. Their site's reasons.org. Our site is truthrevolution.tv. You have plenty of reasons to believe. If you have any questions or challenges to this at all, just email us, let us know. We'd love to help wrestle with any of these things. We reply to every single question that comes in. Thanks for listening. Have a great week.